everyone. So, good morning to all the participants. So, I welcome you all here in the third day, the first session. So, this session, the first lecture is a hands-on. The data is a hands-on. So, this lecture that will take Roshana. I would like to take a moment to introduce the hardworking and with the National Institute of Technology, Jaipur. His research interests include biomedical signal processing, machine learning, and reinforcement learning. So now I hand over the session to Ashutosh Jana. He will take the hands-on session on the CNN, and thereafter one more hands-on session in this first session. This is the third lecture. Again, he will take one more hands-on session on RNN. So now I hand over the session to Ashutosh Jana. Yes.
Thank you, sir, for the introduction.
Yes.
Okay, without delaying, we'll start with the introduction part. So let me just bring my screen. I can view your chats, so if anybody has any doubts, you can ask immediately. First, we'll go through some basics of what we need to know before we start on with CM, like how to handle the data and all those things. I'll start with that. I'll tell you the four key steps or the four I would say that four steps that you should remember all the time if you are trying to implement any kind of deep learning algorithm. So let's start. So first that we make the different
Why is it not?
let me know if my voice is clear now.
Yes, now it is clear.
Okay, so there was some network issues. Anyways, let's first start with the different make while we are coding for CNN, while we are implementing CNN. So first thing that you need to know that there are more than these number of hyperparameters that you can configure. But we are concerned about the little that that may be used that is used most of the times when you implement a CNN network. So first parameters that comes into the picture is that number of filters. So here you can see the number of filters is essentially deciding the depth or the channel information of your image. So when you import your channel, it has something like maybe it has one channel or maybe it has three channels. Sometimes it may go beyond three channels whenever we are making use of medical image data set. And you are making use of, let's say, data set in the format of SDF and NIFTY. Those are basically the scanned images. And in those cases, you may come across channels with more than with length, right? Uh, you will only see. And that have been style or maybe a 7x7 or maybe a 3x3 filter size. I'm not able to see the screen, but one more. Let me check. I think the network is fine on the side. Host is I'm sharing my screen from another device, and I can see clearly when you like host device. So I think it is working on this side. Maybe check the internet connection at yours. Okay, so filter size, you can you can decide if if your image is like 256 and 256 pixels width and height. Then you can go for a filter size of 3 by 3 or maybe a 5 by 5 or maybe a 7 by 7. Basically, when I am about to decide how to choose the filter size, I would go for like I would do a division. Like if the width length is around 256 pixels, then I would divide it by let's say 100 or something like that. And in that case, I will end up with a number, and yeah, I decide my filter size on that basis. Uh, let's say you have a 100 to 1024 into 1024 filter size. In that case, if you go to my calculations, then maybe you'll end up with a filter size of 10 by 10 at the first layer. But yeah, it depends how you change your filter size. Those layers. Like if you're how do you decide so So padding is basically you can say that voice is very much fluctuating.
Yes, sometimes the video is not coming out. Sometimes the voice
Okay.
is being very fast, and sometimes it is not at all there.
Okay. Okay. Got it. Got it. Let me check on my end.
Now it is visible and the voice is also clear, but sometimes it is.
Sometimes it breaks. Okay.
Hmm.
Maybe the network issue. Let me check with the team. Meanwhile, I would really like if you could write it down in between.
It is visible. You may continue
It is visible
for the
now.
timing. Yes, yes.
Okay. So let's say that you want to retain the same image at the end of one of the CNN layers. So that you can do by making use of paddings. Paddings is basically, you can see here, paddings is basically addition of an extra layer into your image. Let's say your image was original 256 cross 256. Now you want to add an extra layer of pixels so that in the future layer you may not lose any data of yours. You don't want to lose any data of your image. In that case, you may choose to go for padding. Then again, padding will also increase the number of parameters that you end up with at the end of the network design. So it is up to you how to set how to go for padding. Like if you want the same number of width and height in your next layer, in that case you can go for a same padding. In any other case, you can also manually pad the data. Like you can add one data at the extreme edges, like I have done here. So that is up to you, really. If you want to keep the size of image at the end of the CNN operations, then the next thing is something called a stride, and I think in yesterday's sessions, sir has clearly explained about how stride functions. Stride is another parameter to not overly go through. You don't want to crowd number of parameters much. So in that case, you can you can go ahead and skip some of the in the while moving your convolutional builder. By doing so, you'll end up with a smaller image size. Let's say if you take stride as 1, then you'll have a larger image size. But let's say if you have a stride of 2, then you'll end up with a smaller image size. That will happen only when you are applying a padding that is not same. In the case of same padding, you'll end up with the same output image size. Anyhow, the next thing that you might come across is the number of layers. And number of layers will basically define how many number of CNN modules that you want to use in your architecture. Right here in this example, I've considered only 3. And if you go for higher end architectures of CNN like ResNet, LeNet, and all those models, then you'll realize that okay, they have more number of CNN layers in their examples. Then you may come across something called as pooling. Uh, you have the option to you have two options there, like you can do max pooling, you can do average pooling. There is something called as global average pooling, and there is something called as global max pooling. And those are basically over those global pooling basically works over different batches of images of samples. and or should I say over different channels of the samples. I should not say batches. Batches is something different. I should say different channels of the samples. But if you are making use of simple max pool, in that case, yeah, you will end up with the the most brightest pixel of out of this 9 pixels that we have. So this basically max pooling basically takes into consideration you can say the brightest or the intent the if you check their intensity and find out which pixel is the brightest and then you pull it out, then that will basically be the result of the max pool. In case of average pooling, you will end up with a blurry. You can blur it out, blur it by making use of blurring kernel, and then whatever comes in the middle of this 3 by 3 matrix, that you can just function. Can you see the activation functions right now? Now, no voice. Okay.
It was freezed at previous slide actually.
Yeah, it came back. Okay, fine. Activation function, there are plenty of activation functions. There are, apart from this, there is tanh and sigmoid, but they are not very ideal. In case of image dataset, if you see, you don't want magnetic things in your as a output to your previous layer. So you can go for softmax and relu. Softmax can be used at the end, and relu can be used in between. 10H is fine, but yeah, 10H people who are really into research using simple dataset and you're working on that, then I would suggest that go for really relu or maybe the leaky relu. Nowadays, leaky relu is being used very predominantly because relu have had some issues and leaky relu tends to fix it. So yeah. There are other parameters other than the architectural parameters. Those were all the architectural parameters that we saw earlier. All those parameters they are used basically to design CNN network, CNN based classifier network or aggregation network or maybe something else. Say segmentation. Now it should be clear. So the thing that you need to notice, that you need to focus on here too, while setting up the hyperparameters during training, mainly at size you need to focus, because if you are making use, because I guided too many peoples, and most of the time what they do is they go for batch size like 32 or 24 or 16 like that, and they are making use. So that is not very efficient, I would say. If you want to make use of GPUs, in that case, I would suggest that go for the maximum thread size that is available with your system. And I guess the least thread size that is available in 810 GPU is around 128 threads. So you can go for 100 thread size in that case, and you can fully consider your GPU. You can fully utilize your GPU. Fine. Then there is a complete research domain in how to select the optimizer type, and research is still going on, how to actually make more efficient optimizer to yeah, I think now you can now it should be audible. Can anybody confirm is it's audible? I think it should be audible now. Yeah. Fantastic. It's a good audible. Hello, is my voice audible now? Is it clear now? Yes, yes. Okay. Let me get back to you in 1 minute. Okay, I think everything is fine now. Let's start again. We were at additional hyperparameters that you may use, that is weight decay, dropout rate, and learning rate decay. So out of these three, I think dropout works. You may use dropout very often. Dropout will simply do like if you don't if you are overfitting sorry, if you're overtraining something, in that case what happens is that particular guy is being more smarter than the rest of the guys. So instead of doing that, what you can do is you can keep aside that particular guy for some time and train the other parameters. In that case, everybody will be trained equally. So dropout is going to do that. If you have a dropout of around let's say zero point 0.2 or zero point 0.3, in that case, 3% of the 30% of the 30% of the, you can say, overly trained parameters will be not trained, and at that time they will simply be noted as zero. Their weighting parameters will simply be noted as zero. Fine. So now that we know what we need to design an architecture and to train it properly. So now we can move ahead and work our way up to how to write a code in Python. Screen is presented. I think it is because it is visible in the live stream as well. So I think screen is presented. In any case, Yeah. So the first thing that there are four basic steps in writing a code to learn with CNN. And in those four basic steps, the first step is pretty simple. That is importing libraries and installing dependencies. What this means is basically, let's say you have an exam ahead of you, and it's open textbook exam. And let's say that you have exam on feminism, right? So the suitable books that you are gonna need is I think you may need a social science book, maybe a book written by some environmental science books and science books in that cases. So then basically works like that. If you want something, then you import it immediately in your code. Let's say if you want to implement deep learning in your code, then you have to integrate a library into it. Only then it will work. That is why we call it Python coding language is basically you can say that is not very heavy like MATLAB and all other competitors. So what you can do is you can import the required books, or in this case the libraries in here and at the top, and then you can go ahead and work your way around your code, right? So I have imported the torch that will be later on used to call the neural network, where the CNN, LSTM, RNN, all of these are kept. And then a function will be required to execute some kind of function inside the deep learning architecture that we have developed. And then we require torch visions and torch vision to do some types of augmentation and transformations, all those things. If you want to do all that, then you will need a torch vision library. And then we require the torch utils data library to extract the I would say the images from the directory that you have stored in. Right. Let's say you have stored your images in X directory, and you can make use of data loader function to get all the images and their labels, corresponding labels, by making use of data loader from the X directory. Okay. The next thing that you need to look into is the pre-processing, basic pre-processing of images. In this case, we are essentially converting the image into tensor form, and then we are normalizing the image data, the I would say the X cross Y image data by a factor point by these factors. So once you do that, what it will do is basically initially you may line with the 1 or maybe 2 to the power 8. So that much variance will be reduced when you normalize the data. That will help during training. Why? Because when you are training the they won't very drastically. Like if you have the image pixels of image like 1, and then there is a 16656 value in some pixels. In that case, what will happen is there is a drastic change between 1 to 16656. And because of this variance, what will happen? Your weight parameters and that you are training, that will change that will deviate by a very high amount. So to reduce that, what we can do is to amplify that effect. What we can do is basically we can normalize the input data. So once you have converted your image into a text and you have normalized it, then you're good to go now for C part, where the data will be uploaded to the CNN and in some batches, and then the CNN will train by itself. Fine. So the next you may need to check is the hyperparameters. We talked about hyperparameters in detail. So in this step, you may need to set your hyperparameters. Let's say your image is like 256 by 256 image. In that case, you come up with a filter size like 3 by 3 or 5 by 5. All those things that you need to set. Let's say you have a lot of data. You have thousands of data. In case you can increase your size to around 32 or 64. If you have millions of data, in that case, you can increase your batch size to around 100 or 128, like that. Even if you have that's you can go for that batch size. In any case, you have to do all this hyperparameters. You have to figure out a way to set all your hyperparameters. This will be fixed once in your code, and then they won't be changed anytime in the code. Then you may want the same architecture that we have used here makes use of two convolutional layers, and then there are and each convolutional layer is followed by a ReLU layer, and then it is being followed by a pooling layer. You can see it right here in the code. So if I define the convolutional layers here, and then in the forward propagation, we are suggesting that okay, you do the forward propagation like this. You take the input data X, then you do the first convolution, which is basically having a 16 filter size, and then the kernel size is 3 cross 3, and you have to use a padding of 1. And then the output of this convolutional filter is being passed through a ReLU, and then it's going through a pool. Now this pool is basically a maximum pool with a grid size of 2,2, right? So it will take a 2 by 2 matrix, and from that it will pull out the maximum values, the brightest value, I should say, in your image. Right. So that will be stored in X, and then the X will again go back to the next convolutional layer, and it will have it will the input of this will be 16 channels in advance. Then you have go to more channels. It will have the other sides of this convolution that has been used here. Then this is up to ReLU layer, and then again pooling layer. Yeah. After that, what you can do is you want to, let's say you want to do you want to classify your image. So you need to come up with labels. So let's say that the number of labels that we have in our case is, let's say there are 5 labels. In that case, the fully connected layer in the end at the end of the architectural design will have 5 here, not 10, 5. If let's say there are 10 classes, in that case you can go for a 10 in here. This is basically the input that we are getting, and the input to this layer is 128, which is the output from this layer. Right. So to convert the 2D matrix into a 1D matrix, then again we have to go for something called as flattening of layer, and that flattening of layer is being done by this piece of code, and then we are jumping on to making jumping on to the fully connected layer, and then the second fully connected layer is going to give you the output. Basically, it will give you some value between 0 and 1, or maybe some value between 0 and 200 or 100, like that. But then you have to pass it through a sigmoid function or maybe a softmax function and convert that into some value between 0 and 1. Fine. So at the end of this, you will end up with 10 by 1 array. And in that 10 by 1 array, you will find values between 0 and 1. So how to decide which class to pick from that 10 by 1 array? Is values. You have that one array, you then you say name along this class and set in this code. Right now we have not class analysis, because there could be different outputs to this particular image that you have with you, and accordingly you can change your loss there. Your optimizer in all the cases can be same. It could be the Adam optimizer, and maybe if you're working on some good optimizer, then you can make use of that optimizer instead of this. Anyways, this is the pre-training setup. Then let's talk about what happens during training. During training, what happens is basically you have decided the number of epochs, the number of batches in the beginning of this presentation. We have decided that okay, we are down to this 32 images at one time. So batches basically mean that let's say if my batch size is 32. In that case, what I want to say is that at a time, consider 32 images at one time and send them parallelly to your devices. And the devices will be decided by the piece of code that we wrote in the beginning here. It will decide whether you want to use the GPU or the CPU, and based on that, you can decide your batch size. So let's say if I have a GPU and I'm choosing a batch size of 32. In that case, the 32 images from your sample. Let's say you have a sample of sample length of around 1,000. So from that 1,000, 32 randomly 32 images will be selected, and those images will be parallelly passed through your device, and they will be computed parallelly. All those CNN design modules that you have designed during designing of the architecture in the previous step, all those will work simultaneously on each of this data. Uh, network once again by making use of this backward propagation piece of code. And then, yeah, you can update in this particular line optimizer short script. You'll be updating your weight parameters. And before jumping next level of let's say you want to do the next iteration. In that case, you need to make your DW, that is the difference in the weighting parameters equal to 0. For that, we have made use of the optimizer.zeroGrad function. Right. Are all just for your convenience. You can make use of print commands. You can make use of visualization commands to see the graph and print what is the current status of your training. Then you can go for testing this model. But yeah, let's now jump into the Python environment and let me show you it's working. So I guess you can see my screen now. Right now, is this is a basic implementation of convolution. We'll come to this later. First, let's do the previous one. So here we are making use of a dataset from Kaggle website, and that dataset basically contains the images of dog and cat, and we have to classify whether the image belongs to that of a dog or that of a cat. So it is always customary to use the link provided by the dataset provider, and because that is much convenient to make use of while you are working with Colab. We're going to set the number of epochs to 2 uh, so that we can cover up immediately. If you have any sort of queries or in any sort of doubt in whatever I have explained till now, you can go ahead and put it in the comment section. I am always seeing your comment section. how to know whether it is running CPU or GPU depends on whether it is running CPU. If you are making use of something that you is like if you have made use of if you have made use of aspatch commands to utilize the GPU, to utilize the script file. In that case, you may have to check with the SQ command to check whether there is code running in your GPU or not. But yeah, if you are doing it on MATLAB, MATLAB will simply tell you that okay, GPU is being used now. In the graphical user interface itself, it will tell you that okay, currently if CPU is being used, then it will say that parallelly this much of threads are being used in the CPU. But if GPU is being used, then it will say that the GPU it will come in the command window of the MATLAB. The other way around, if you really want to check whether your hardware has been utilized or not, in that case, you can go for NVIDIA SMI and you can see whether proper amount of task has been done by the system or not. Then the next thing is, sir, can we apply CNN in some behavioral biometric based authentication system? Yeah. You can. There is applications. This is application oriented question. CNN in some behavioral biometric based authentication system. I don't know if you have gone through if you watch too much movies, but if you go through one of the Mission Impossible movie, in their movie they have shown that their gate pattern is being tracked, and by utilizing that they are opening their bank accounts to somebody. So the next level of authentication system is going to be gate based authentication system, which is one of which is in some sense you can say that it is a behavioral biometric based authentication system. If I'm correct, if I got it out correctly, then there is not an image based data given. Okay. Yeah, you can use, you can, if it's in the form of 1D array, then you can go for 1D CNN. Currently, whatever discussion we had, it was on 2D images, 2D dataset. But let's say if you want to make use of array based dataset, in that case, obviously you can go for 1D CNN. On Windows, you can check CPU cores are utilized or GPU cores via task manager. Otherwise, it will also show on output of terminal window. Yeah. That's one way to look at it. VS Code then CPU and GPU cores. Issues, then I can ping my email ID. Then you can ask me in my inbox. What size of the data taken in this code? Okay, the data size may be very large. I'm not sure. I have to check. Let me check immediately. I think dog and cat classification data set. You can see from Google. Kaggle. Get my voice? Please. So you can see that the data size is too big. It is around 25,000 images. Okay. Is there any other doubt, or probably this will not be ending sometime today? So maybe I'll share the code later with you. And this is a functional code, so it should work with newer systems as well. If you are willing to do it on Colab. If you have any other doubt, then I can address it. You can ask your doubts related to MATLAB, Python. Okay, if there's no more from the audience, then please explain optimizer and loss function. Okay, so optimizer is basically an optimizer algorithm you have to set to reduce that loss function. Loss function is something you can say there is you have an annotated data set or a labeled data set, and you want to see in supervised, let's see that to that labeled data that you already have. So what will you do is basically you will take the predicted output and then subtract it from the original or the actual output, and then take some kind of function of it that we call as a loss function. And then that loss function, now you want to minimize the error between them, right? The error in the coding, error in the model. So if you want to do that, you will have to minimize the loss function, and to minimize the loss function, you are making use of that optimizer that we have in our system. So with iteration, with successive iteration, the optimizer will be reducing that loss function. Meanwhile, it will do so by updating the weight functions inside of the network. And here the weight functions are inside of that kernel that we are seeing. In Colab, do we need to explicitly specify in code to use GPU? Yes, you have to. Otherwise, it won't consider the GPU. Right now, I think I showed you that piece of code. Yeah, you have to mention this piece of code to make use of GPU. This piece of code is same everywhere for whatever data you use. So you can use that in your case as well. The only thing that you need to change when you're changing the application is the layers inside of it, the loss function, and yeah, the how you process your data. These three things are required to be changed every time you change your applications. The rest of the things can remain the same. In the second half, I'll show you how to do that in RNN, so that it will be easier for you. If there is nothing else, then maybe we can wind up this session. and move ahead to the next session. Okay, thank you, Shashwati.
Okay. So thank you, Ashutosh. Now the next session that we will start at 11:30, and thereafter there will be a hands-on on RNN.